For this brief flight, I'm going to teach you how to use a multimeter, which is what this device is you see here on the left. They come in all different shapes and sizes, but in general, there's a couple of trends about every single multimeter that's going to be the same. This is very similar to ones that we would have in our lab, assuming we could do labs. So you'll see this dial has a plethora of options on it. We see we have 1, 2 buttons here, and then 1, 2, 3 ports here, and then 2 probes. You need a battery to power the multimeter itself, which is why in this particular image that I found on the internet, they gave a battery. So there's 3 things that we're going to focus on being able to test, and that is voltage, current, and resistance. So voltage, current, resistance. I always want to start off by saying the first rule should be you should never touch metal in a live circuit, just in an effort to avoid electrocution. So as you see, these probes have a hard plastic cover and then a metal tip at the end. When running tests, you should not be touching those pieces of metal. You'll see when we measure resistance, it's actually okay to do so, but that's because it's not really a live circuit. So if the circuit is dead, then you can touch the metal, that's fine. But if the circuit's live, never do so. So for example, if I'm going to go ahead and run a test on, say, a wall of receptacles you see here on the right, never ever under any circumstances touch these metal probes. Keep your hands on the plastic. All right, so let's start with voltage. You see we have voltage shown in 2 different categories. There's one over here, and there's another set over here. You'll notice 2 things. One of them is this is voltage, and then it has a line with 3 dashes. So line, 3 dashes. I'm going to tell you right now what that symbolizes. That's for a DC circuit. And then we see here voltage with a tilde symbol. And that's for an AC circuit. So universally, the line with the 3 dashes underneath stands for DC or direct current circuit, and the tilde stands for an AC or an alternating current circuit. Before measuring voltage, you should know whether it's going to be a DC or AC circuit. For example, if I want to check to make sure that my wall receptacle is at 120 volts, I'm going to dial into AC because the power plant naturally delivers AC or alternating current to your house. If instead we hooked up a battery with some wires and a light bulb, that's DC. So I'd want to use a DC circuit. The other thing you'll notice is that it starts 500, 220, 2000 milli, 200 milli. And the other one's still 500, 200. So it starts from high to low. And it's done that way on purpose. You start at high numbers and dial down to low numbers. You start at high and dial to low. The lower numbers give you a more accurate reading. The higher numbers are safer for the meter itself. It prevents the meter from essentially blowing its fuse. So on the wall circuit, it should be 120 volts, but maybe this particular receptacle is actually designed for an electric oven, in which case it'll be 240 volts. But you, as a homeowner, might not know that. So you want to make sure that you do understand, is it a 240 volt or 120 volt? So what you would do is you would dial into 500 first, check the reading. If the reading comes out and says 120, okay, good. Now you can dial down to 200. Now the meter might say 121.2. So what the meter did is it gave you a more accurate reading on the lower number, but we start with a higher number to ensure that we're not going to damage the meter. As for measuring voltage, what you would want to do, and I'm going to go ahead and pull up some circuits here. Let's say I have a series circuit like this one shown here, and I want to measure voltage. So I'm going to take my voltmeter, and I want to check the voltage on this battery. Drop the probe on one side of the battery, drop the other probe on the other side of the battery. I see my battery is operating at 9 volts. Excellent. If I want to see how much voltage is this light bulb consuming, put the probe on one side of the light bulb, and this probe on the other side is consuming 4.5 volts. Wonderful. Same thing with this. If I want to know, well, what's this light bulb in the middle doing? Probe on one side of the light bulb, probe on the other side of the light bulb. Light bulb consumes 9 volts. Now you'll see the last thing is 2000 milli, 200 milli. All right, so let's say I dial in specifically right here at 2000 milli. That means the maximum voltage that the meter can handle is 2000 millivolts, which is also known as 2 volts. Now, if the display screen, when you dial to 2000 millivolts, if the screen says 1436 and a decimal, what you, the operator, needs to do is use your brain and realize, since you dialed into milli, what you're actually looking at is 1436 millivolts, or 1.436 volts. You'll see that the same thing happens here: mega, mega, kilo, kilo, milli, milli. You have to pay attention to those. This display screen is not going to tell you the units. It's up to you as the operator to be intelligent enough to know what the units are. Moving on to current. Current, just like voltage, is measured, with micro, milli, so on and so forth. And you ideally want to start with the higher values and move to the lower values, just to be safe. Now, there's an exception to that, and that exception is going to come in the form of this 10 amps. One of the things I have not talked about yet is these ports down here. So, for the purposes of our class, the black probe is always going to go into COM, or COM, which stands for common. The red probe will go into one of the other two. You'll see that this has volt, omega, milliamp, and then the other one is 10 amp max. Okay, so the 10 amp max is typically unfused or fused with a different higher level fuse. And if you are dialing into the 10 amps, you would put the red probe into here. Otherwise, if you're measuring voltage, if you're measuring resistance, or if you're measuring one of the lower level currents, you would put the red probe into here. Current, unlike voltage, you're going to actually plug this meter into the circuit. So if I come back here and I want to know, well, what is this particular setup here is actually designed in a different way than we would normally be using. So let me have a moment to build a new circuit for you. If I want to measure what is the current traveling through a single light bulb when it's connected to a battery, no problem. What I need to do is put the meter directly in the circuit. Now you notice here, this looks a lot different than, say, this one. Our meters would actually look a lot more like this one, and what we would do is cut this out and we'll delete this. We would be putting probe here and probe here, and this would actually be a part of the circuit. Now this wouldn't be set to voltage, it would be set to current. All right, let's go back into here. The last thing to measure is resistance. So resistance you will find here. You may be thinking, well, what about this stuff? We're not going to worry about these, so don't worry about them. Resistance is never measured in a live circuit. What you do is, if you want to measure the resistance of something, is you physically remove it from the circuit. So let's go back to our example here. Allow me to have a moment to basically delete everything that we see. Delete, 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 delete. Okay. Now, let's say this is our meter, and I know it says voltage. But let's say I could dial it to resistance. I would take one probe, put it on one side of my resistor, put it on the other side of my resistor, and it would tell me the resistance. Now, a few things could happen with the display screen. One thing that can happen with the display screen is it could read, and each one's a little bit different, but typically the ones I've used just read a 1 and then nothing. What this tells you is that you effectively have infinite resistance. Now, infinite resistance means you're not going to get current to run through this. Or it means you've dialed down too low. Perhaps your resistor is 1,000, but you chose to dial into 200. 1,000 is bigger than 200, so the meter can't actually read it. If you go ahead and dial now to the 2,000, meaning that the maximum it can read is 2,000, it would be more than capable of reading the 1,000 ohms of resistance. The other display thing that we tend to see, 0.0. That means no resistance. Ideally, to make sure that your meter for resistance is calibrated correctly, one of the first things you would do when you dial into 200, take the two probes, have them touch each other, and it should read 0. What that's doing is it's saying that the meter itself has been calibrated so it is not creating resistance in the circuit. Again, with resistance, starting high and dialing down is optimal. It's not as big of a deal because you are not in a live circuit. So it's not as important for safety measures. It is very difficult to damage the meter when measuring resistance. The number one way you would do that is you measure resistance in a live circuit. You don't ever want to do that. You physically shut off the power, remove the item that you would like to measure the resistance of, measure the resistance, then put that item back into the circuit and turn it back on. Well, that's a wrap for this pre-flight.